Hey everybody, it's Mr. Dawson once again with more math videos. So what we're going to do today is we're going to look at using the Pythagorean theorem without dot paper. Finally, we can get rid of the dot paper and we can now just use some regular paper, maybe even just a worksheet, who knows what, but no dot paper. And you may be asking, then why is there dot paper on your screen right now? Well, the reality is I'm going to show you one last time how the dot paper thing works, and then I'm going to give you a general rule that we don't have to use the dot paper for anymore, and it's just going to like go away. And you know, some of you probably already figured this out, but one last time, we have learned that we can use this dot paper to find the distance between 2 points by connecting the dots, making a triangle, a right triangle. This only works with right triangles. That is really important to know. Finding the areas of the squares of the legs, and then adding those areas together to find the area of the hypotenuse. And we don't even have to be picky about this one. So we do that, we take the square root of that side, that area of the hypotenuse, and we figure out our distance between the 2 points, in this case square root 5. So that's great, but what if you don't have dot paper? And that's going to be very real, and there's times when you don't have dot paper and you have to be able to do this problem without using dot paper. So let's head on over to the next page. This is where I want you to start taking notes. So this is where you need to take out a piece of paper, do your 3-column grid, and I'm going to show you something magical. And you know, when we talk about the Pythagorean theorem, there is always one thing that people hear over and over again, and this is what most people think of when they hear the Pythagorean theorem. A squared plus b squared equals c squared. This formula right here is essential for you to understand, and you need to know this series. A squared plus b squared equals c squared. And right now it probably looks a little bit confusing and you're thinking, God, that looks a little scary, but it's what we just did right here. This is exactly the same thing, because if you think of this leg, or either of the legs being A and the other leg being B, A is only one unit, 1 squared. That's our A squared. Plus b squared. Well, b here is 2 units, 2 squared, and that's our b squared. And that equals c squared. And we already know that when we add these two areas of these two squares together, we will get the area of the third side. So whatever this side is times itself, c squared. So in this case, 1 squared is 1, 2 squared is 2 times 2, that's 4, and that equals c squared. So 5 equals c squared. Okay, that's great, but there is that last step where we have to take the square root of 5. Okay, square root of 5. Square root of 5, we can do that, that's no problem. But in equations, if you do something to one side of the equation, you have to do it to the other side. So we have to take the square root of c squared. Curious. Well, what does c squared means? It means c times c. And the square root is asking what times itself will get you the number underneath the square root. Well, c times itself will get you c squared. And so if you take the square root of c squared, you will just get c, which is the length of the hypotenuse that we want to find. So the square root of 5 equals c. And that is our answer. So let's take a look at the one that you're going to draw, you're going to write out. So if I give you a triangle, let me pull out my shapes here and get you a triangle going on. I like this one better. So here's our triangle. Okay. And I'm going to tell you that the length of this side is 4, and the length of this side is, gosh, I don't know, let's call it 8. Okay, so those are the lengths of those sides right there. We want to know what this length is here, the hypotenuse length. All right, well, let's take a look. Remember, A and B, those are your legs. Doesn't matter which one's which. I can say that 8 is my A or 4 is my A, and as long as the other one is in there, it's all that matters. So I'm going to put in my 4 for A. I'm going to say this is my A, and that's my B. Again, it doesn't matter. You can switch those around. No big deal. So 4 squared plus 8 squared equals C squared. Remember how I had you memorize all the perfect squares? Well, this is one of the reasons for it, because 4 times 4 you should know now is 16, 8 times 8 is 64, and that equals C squared. Okay, that's not too bad. Add these two together. The 6 and the 4 make 10, so that's going to make this 70, plus another 10, that's 80, equals C squared. Okay, well, you know, oh right, we have to do the square root of both sides. And the square root of 80 is not a perfect square, because we know that 9 times 9 is 81. And so it's a little bit smaller than that. We can leave it as the square root of 80, or you can estimate either one. It'd be very, very close to 9, 8.8, 8.9, something in there. And that equals C, because the square root of C squared is just C. And that is our answer. No more drawing squares, adding it all up, none of that stuff. You just have to take the square of each of the legs, add them together, and take the square root, and you are done. One more example, and then we're done for tonight's homework. That was a pretty fast and easy one. And we're going to be doing this in class, so just be ready for that. And let's see if I can get a taller triangle. Nah, it's not going to let me do that. But that's okay. We can use this one still. All right, let's call this one 6 by 7. 6 by 7. And again, we want to find our length of this line here. So pause it. See if you can do this one on your own. Try doing this one on your own. Okay, let's see how you did. Remember our basic formula, a squared plus b squared equals c squared. Again, doesn't matter which one's which. I'm going to make this a, and I'm going to make this one b. So that's 6 squared plus, oops, almost went to the next step. I almost wrote 49, but not yet. 7 squared equals c squared. 36 plus 49 equals c squared. Add these two together, the 6 and the 9 make 15, which makes this 55, plus the 3, that makes 85. 85 equals c squared. Once again, we know that 85 is not a perfect square because it is a little bit bigger than 81, but not as big as 100. So I will take the square root of both sides, and I get the square root of 85 equals C, and that is my answer. Again, you're welcome to estimate this. It's a little over 9, say 9.2, 9.3, something like that. But you can leave it as a square root as well. And that is using the Pythagorean theorem with no dot paper, much faster, much more lazy. You know how much those algebra folks love to be lazy, and so this is all about being a little lazy. All right, time for your joke. Why was the math book sad? Because it had so many problems. Too bad. Okay, have a good one, and I will see you in class.